So
thank you very
next
much.
we have Cayrou from University of Leicester.
So hello, I'm Caroline. So today I will present you some preliminary data about exploring the contribution of preservation to colonization, gastrointestinal spread, and evaluation of chicken by Campylobacter jejuni. So preservation is a mechanism that is used by various bacteria to survive environmental changes. In Campy jejuni, at least, this mechanism is mainly based on a poly-G tract that will vary in size because of replication errors. And it can have various effects, two different effects on the protein. If it's in frame, it will cause a frame shift that will switch on and off or off and on the protein. But it can also be in the antigenic region. In this case, it will modify the level of expression of the protein itself. So in jejuni, we observe that PV genes are mainly involved in the formation and the glycosylation of important structures, as the flagella, the loss, and the capsule, but it can affect other genes involving the metabolism and other function of the bacteria. Previously, we know it has been observed that phase variation is involved in bacterial survival for phage, but there is also indication that it's involved in colonization and invasion of the host. So we are particularly interested in the phase variation linked to the spread of in the organs because it seems it may be a mechanism for the bacteria to survive the stage of the food chain and persist later and cause some infection with chicken liver party, for example. In addition, recent evidence show that jejuni can elicit inflammation in the intestinal tract, and so that can eventually lead to a spread into internal organs, and we want to see if PV can be involved in that. So the objective of the study is to explore whether if phase variation contributes to inflammatory response and the spread of the jejuni in the chicken. So we perform an in vivo experiment in chicken broilers. So we use various strains, two common laboratory strains as a control, but also we use some chicken isolates that belong to two connect complexes, ST354 and ST353. Those isolates were previously isolated from the same chicken from the same flock, from the ceca, villia, and the liver was chicken. Interestingly, the 464 isolate seems to be more frequently isolated from the liver and also exhibited a slightly higher invasion level in vitro. So it's for that we wanted to test them. So for the in vivo experiment, we gave us two groups of chicken with 9 isolates and also a mixture of 353 and 464 isolates. So as I said, the laboratory strain and some of the isolate from the two STs. After 7 days and 14 days post-infection, 10 birds were sacrificed and we quantified the presence of bacteria in the ceca, villi content, the liver and the spleen. For the phase variation analysis, in fact, we look at it at 14 days post-infection, and for that we pick colonies from the counting plate for 5 birds in the ceca and the liver samples. And for the liver, we took all the colonies because it wasn't that concentrated if we took only 5. So here we have the result from the colonization and invasion counts. So what we observe is that in the ceca and the spleen here, there is an increase over time of the bacterial concentration for all those samples. But for the ilia and the liver, the increase is not that consistent. It depends on the isolate type. In terms of phase variation, the first thing we have to do is to identify the phase variable genes, because for 3.68 it was already known and we already have an assay to test them. But for the M1 and for the ST353 and 464, we didn't have any, so we analyzed them by phasomate to identify the phase variable genes, and we saw that it was between 11 and 33 genes. And after we performed fragment length analysis, that allows us in fact to amplify the fragment containing the poly-G tract, and based on the size of fragment, you can predict the repeat size using PS analysis, and then determine the distribution in the population of each repeated size tract. So here is preliminary results obtained from this in vivo experiment. So here is for M1. For M1, we observed that 3 genes seems to exhibit a switch of phasotype between the inoculum and the chicken. So you have TRIP16, that is a putative serial hexamerase, that in the inoculum is mainly off, even if it's still diverse. And when you look in the chicken here, it's switching on. So there's 0540 that in this case, we don't know the function plus it's an intergenic repeat tract, so we don't know exactly what is the effect of a change of repeat tract size. But what we can observe is that in the inoculum, you have 11 Gs that disappear in the chicken. So it seems again that there is kind of a selection. And the final gene is 1277, that is an aminopeptide associated with localization of a flagellin. And what we can see is that the inoculum is mainly on, but in the chicken, it starts to completely switch off. So in the cecal and villi, but mainly, but also mainly in the liver and the spleen. For 3168 and the 353 isolate, so we observe only 1 gene that may be switch between the inoculum and the chicken for each. So for 3168, we have CJ1429, that is a capsule biosynthesis gene. That switch here you can see from nice mixture of on and off population to a completely on population in the chicken. And for 353, we have COM1252, that is MAP4 equivalent, and it's linked to the flagella. That seems to switch on in the chicken, as you can see here, the inoculum is mainly off, and in the chicken here it's on, and we observe that for some of the samples that we took for over isolate in the chicken, where here you see the switch too. So in conclusion, no clear difference were observed between the laboratory strain and the chicken isolate we tested in the in vivo experiment in terms of gut colonization and invasion of spleen and the liver. However, we have good indication that there is some PV genes that may be involved in colonization of the chicken, as we saw switches between the inoculum and the chicken in terms of phasotype. We still need to do some additional in vivo experiment to confirm that, and also we need to do some combinatorial and changes analysis in PV genes to see if it's true. So the interesting thing with PV genes is that we can, if it's confirmed, if they can be subject to further analysis and see if it's if they can elicit, for example, inflammation or things like that. But the thing is, it doesn't seem from now that PV preservation is involved in the spread of itself as jejuni within the chicken, but we still have some data to analyze, so we will see a bit later if it's confirmed. As a final word, I want to thank all the collaborators, because this study is part of a bigger project, is CampAttack, that is funded by the BSRC, and we work with Swansea, Atbury, SRUC, and Newcastle, and Emerging Animal Health for this project. Thank you.
Okay, thank you very much, Caroline, for this very interesting talk. There are already some questions on Discord. So Tom Wilkinson asks, or says, great stuff, Caroline. You mentioned a sugar isomerase. Do you know whether this is specific for a certain sugar?
No, I don't know yet. As it's a putative one, it's just a prediction from blast analysis. So we will need to look a bit deeper to identify the sugar that may be involved in.
Okay. Then Ozan asks, apologize if I missed this, but would the phase variation flip to different types if your experimental model sampled over time?
So can you repeat?
He asks if the phase variation flips to different types if your model, if your experimental model sampled over time.
There's a possibility that, yeah, the phasotype change if over time, because if you are looking at acute infection and after for chronic one, I suppose. It's for that we are in next in vivo experiment, we sample at 7 days and 14 days to see if there is any difference in the phasotype at different stage of infection.
Okay, then maybe one last question. Aldat Soma asks if these are any homopolymer tracts or only poly-G in your analysis.
There's only one over that is a poly-A tract, but we never seen for now any switches in poly-A tracts. And in general, we need to consider them a bit bigger because Campy is HE rich. So obviously there's kind of few tracts of A and T's in the genome. But there is one gene for some other isolates that show poly-A, and we added it in case.
Okay, then thank you very much again. Remaining questions can be asked later, also in the Q&A session.